Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, we continue to explain integration, and we are talking about we are in page P1, page 171. We have just introduced ourselves to the very last topic. And today I want us to look at example 2, and see what we can do. Find fx, we are talking about find fx, the function of x, or rather the value of y for 1, f prime x is equal to 3x raised to power half. And this one, it goes without saying, this one is a gradient function. And this gradient function, we need to integrate it to go back to the function itself. And the process of integration is, this one we simply integrate, to get 3 remains where it is, x, the power increases by 1. So a half plus 1 is 3 over 2. And this new power becomes now the divisor, which is 3 over 2. Of course, we add a constant. We will hear in the next video that we always add a constant when we are dealing with indefinite integral. Indefinite integral is that which does not have boundaries. I will show you what boundaries are, or rather the limits. To clean this up, it's going to be anytime we divide by a fraction, it's like multiplying by its reciprocal, and therefore it's going to be 2 over 3 times 3 x raised to power 3 over 2 plus c. Of course, these 3 and 3 will cancel out, and the final submission will be 2 x raised to power 3 over 2 plus a constant. Remember, every time we divide by a fraction, it simply means we multiply by the reciprocal of the divisor, and that is why we have taken that step. 2, it's talking about the gradient function f prime x is 3. And if this is the gradient function, we need to integrate it. Integrate it. And how do we go about integrating it? Simply the integral of 3, which is, this one is already naturally having x raised to power 0, because any number raised to power 0 is 1. And since we have 3 times 1 is remaining 3. So the reason why I have introduced x here is to bring the aspect of integration, because we integrate with respect to a variable. We integrate with respect to a variable x or any other variable. So once we integrate, this becomes 3 remains there as a constant. X, now the power becomes 0 plus 1, that is 1, all over 1. And finally, if you clean this a little bit, you're going to get 3x. And that is simply what we expected to get. Of course, there is a plus c there. Of course, there is a plus c there. So don't forget to add c. And what have we understood? That if we understood that if dy dx in these two examples happens to be kxn, then the y, or rather the function itself, after differentiate, or rather integrating, this becomes kxn plus 1 over n plus 1, of course, plus a constant c. And if we're talking about the function, the differential function, which is kx raised to power n, then the function itself becomes, you may want to treat k like alone, but there's no difference. You can write it like k over n plus 1 multiplied by x n plus 1 plus c. It's one of the same thing. It's one of the same thing. And of course, please note, n is not expected to be -1, because if it is, then it nullifies the denominator, and the whole of that expression becomes not known, or because any number divided by 0 is not defined. I don't know whether we can look at example 3 in the same video, because we have just one more example left here. And in this case, I would want to go to the next page and explain something to do with example 3 on the same page. So we're saying that if dy dx is equals to 6x plus 2x raised to power minus 3 minus 3x raised to power a half raised to power a half, yes, find y. And it goes without saying that we have a function, a gradient function given to us, and we are expected to get the value of y. It goes without saying that we must be able to integrate the whole of this function. So therefore, this is the integral of 6x plus 2x minus 3 minus 3x raised to power half with respect to x. And it is indefinite integral, and therefore we have no lower limit, we have no upper limit. And because they are different terms and all of them look quite independent, or they look cleaned up, then we can integrate polynomially. Polynomially means a term after the other. And this one is just going to be 6x squared over 2. The power increases by 1, and that new index becomes a divisor, plus 2x minus 3 plus 1 is minus 2 over minus 2. So you can already see that this new index becoming a divisor is going to eventually make the term 2 being negative. And minus 3x, a half plus 1 is 3 over 2 over 3 over 2. What we need plus a c. What we need now is just to clean up, because the first term is going to give us 6 over 2, which is 3x squared. And this one is going to give us minus 2 divided by 2 is 1, so minus x raised to power minus 2. And this one again, dividing by a fraction means multiplying by its reciprocal, so it's going to give us minus 3 times 2 over 3 x 3 over 2, of course, plus c, and this one now is going to give us minus 1. You can see, so the final submission, because 3 cancels with 3, we're going to have 3x squared minus x minus raised to power minus 2 minus 2x raised to power 3 over 2 plus a constant c. And that is just like what we expected. 3x squared minus x raised to power minus 2 minus 2x raised to power 3 over 2 plus a constant. And there we are. This is example 3 in the same video. All right.